So the next model we're going to talk about is actually not a model, but more of what we call a framework. And the reason for this is that we can actually use models within this model. So throughout this process, we can use different models like the waterfall model or the V model or sashimi throughout this every single step within here. And so we're not sort of constrained to a single model. We're basically have a game plan or a overview of what we're trying to get done, and then from this we use models to accomplish those tasks. So this is the unified process framework, and there are a lot of deviations of this, probably maybe upwards of 20 different deviations of people who have looked at this and tried to come up with one that solves a specific problem. For example, there's one called the rational unified process model. There's one that's a very lightweight one. There's one that's specifically designed for more things like agile. There's just a lot of different iterations because this is a very good way of capturing the idea of software development and then sort of giving a really neat overview of it. So this is sort of the graph over here on the left of where we spend our time. We have these different phases called inception, elaboration, construction, and transition. And these right here are sort of basically placeholders. If you're in a company, you would create your own I's or E's or C's or T's, and each one of these would have a goal at the end of it. So in each construction phase, you would put a goal at the end of the phase, and that's how you know if you've moved to the next phase, is once those things have been completed. And this is just trying to give you an idea about how this process works. So in the inception phase, we are determining the feasibility of the project. Can it be something that we can build? Is this even possible? We look at the potential project schedule and cost, try to estimate, how long is it going to take, how much is it going to cost the company, what's the return on investment. Then we decide, do we want to buy or build it? Maybe there's a solution out there. Maybe there's a partial solution out there that we can purchase the partial solution and build from there. We need to look into that in the inception phase as well. And then the deliverable or the goal for this is to try to get some life cycle goals, try to figure out the plan, figure out where we're headed, what the cost is, who we need to hire, stuff like that. And so that's in this inception phase. And you'll see that we have these sort of what we've been talking about this whole time down the left side here. We got the requirements, the design, the implementation, the test, and the deployment here. And then this idea of business modeling, which is just that idea of, costs and people to hire and things like that. And so you'll notice that in the inception phase, what we're doing is we're doing a little bit of requirements, sort of maybe giving a rough sketch of what we're trying to create, but we're really business modeling. We're figuring out, is this something that our company wants to spend the time and the resources to build? And that's important because we don't want to build something that isn't going to make us money in the long run. And this is a great way for risk management. Instead of jumping into a project and spending a whole lot of money, we spend a tiny amount of sort of exploratory money up front and figure out if this is good for us. Once we're out of this phase, once we have an idea, we have some check marks, we say, yeah, let's go ahead with it. We move down into the elaboration phase. The elaboration phase is where we take this idea, this idea that we had in inception, and we build it out. We come up with the requirements. So this is where the requirements come in heavy here. We address the known risk factors. We verify and validate the system architecture. So in that case, we're actually going to potentially build the very core prototype code for testing. So we're going to build a very, very loose sort of idea of code that's going to talk to each other. It's sort of going to do what we have, but it's basically going to show us that it's possible. Basically, proof of concepts is what we call these. So we're going to type out some code, see if it works the way that we think it's going to work, and from there we can really start, elaborating it on it in the construction. But in this phase, we're doing just a little bit of that, and that's why you can see the implementation goes up here. We're starting a little of the implementation, again, to try to figure out, can it be done, and if so, in what way? We're doing a little bit of testing because we need to see if it's doing what we think it should be, and then deploying, we're deploying it to other people, we're giving it to testers, we're showing people that, hey, this proof of concept actually does work. And then this is heavy in the analysis and design as well. So we're building use case diagrams and class diagrams and architecture diagrams, etc. In construction, with the construction, what we're doing is we are building the thing. So we're actually working strongly in the implementation here. We are going to put all of our resources into this, and this is the longest and the largest phase of the project. You can see by this that they elaborate it with multiple C values here. multiple different phases and sort of ways of going through this. The system is built on the foundation laid out by Elaboration. So we've built this sort of architecture, this very small model, or maybe even a little project. And from that, we're going to build out from there. Features are implemented in short time box iterations. This is important. This means that we are building out basically fully working end products without features. So we have, of course, that, it starts off with the box, and later on we add the features. Like if it's a car, we add the wheels, and later on we add, the windshield, etc., etc. But what we're doing is we're starting off with a workable unit. So here, even we could put square blocks on here. It's still a car. It still is able to be driven. But over time, we're making it better and better and better. We're adding more features. We're getting a little bit of feedback, and we are adding more features because of that feedback and making better and better iterations. And this is, again, along that idea of iteration. Remember iterative and incremental? Well, this actually accomplishes a little bit of both. In the tiny parts here, what we're doing is we're incrementing. So we're doing tiny increments up until we make an actual iteration. Once we finish an iteration, we deploy it, get some feedback from it, and we start again into tiny increments until we get to that iteration, and so on and so on and so on. And the deliverable here is a continual stream of improving software. So we're going to have, this is where we have the version, I believe it usually starts with like 0.1, then we get 0.2, 0.3, etc., where we actually start coming up with these version labels as we get better and better. And finally, we have this idea of the transition. The transition is where the system is deployed to target users, feedback is received, refinements are made, and the deliverable is, once this is complete, the final product is complete as well. So in the transition phase, most of our design is pretty much done. We're winding down deployment, we're refining and making sure the business modeling and requirements are completely fine. The testing phase kicks up here, and we really begin the deployment phase where we give it out to people and see what they think about it, see if there needs to be any changes, if we need to make a couple of more iterations on the final project. And so with that sort of idea, with this idea, we have a framework on which we can sort of create our plan. So this isn't something that, you can look at and there's going to be a 1, 2, 3 guide on how to create a unified process framework for your project. All it is it's just these groups and this sort of outline of what you should do. And then from that, you have to develop an entire plan for your project. Because of this, we have certain pros and cons associated with this. The pros are it's adaptive, it's quality and reuse focused. It's focused on risk management. At every step, we're sort of reevaluating the requirements, figuring out if we do need to keep continuing or if we should abandon the project. Flexible to incorporate other models. We can, like I said, include other models and areas in each one of the steps. Each increment, we can change up the model entirely and work from there. The cons, though, are if you looked at this and said, well, how do we actually implement that? Well, the way that you do it is you need a whole lot of good managers and skilled people to come up with this plan from the beginning. It isn't easy. It isn't something where we can just look at it and go, yeah, okay, let me just get out a piece of paper and write this down really quickly. It has a lot of overhead, and that makes it very complicated. It's going to have way too much overhead for small scale projects. If you're going to, and small scale is something even as big as like an app, like an application on the App Store that just does a single task. Let's say maybe it's a game on the App Store. That might be too small of a scale for this to actually be a workable framework to use. And so that means you have this really large thing where you don't have a lot of projects that fit in this. We're talking really, really large projects or projects which have a lot of different disciplines involved. So, things that contact servers and different APIs and things that are built on the front end and the back end and all of this different things. That's where this might be justified but for a lot of projects, this is way too complicated. And also because of the way that it's designed, because of this way of where we're doing all the phases at once, and we're potentially working on different models and iterations all at the same time, it's going to need more resources. We're going to need more programmers, more managers, more testers, more basically everything, more money to get this thing done. And the timeline as well is probably going to be pretty fast, but it's going to cost a whole lot. So we have to weigh that. Is the speed of it important due to this cost? But that is the Unified Process Framework. I definitely go look this up on Google or something and look into it a little bit more, because there's a lot of different variations of this, and they're all pretty neat and good to understand whenever you're learning about software engineering. But this is a very important thing, and this is actually one of the most used frameworks within the industry today.